I was thinking the other day, just waiting around, how often do we actually consider our path through, well, not just space, but time?
Hmm. Probably not very often in everyday life. We focus on where we're going physically.
Right. But the reality is kind of mind-bending. We're not just moving in 3D, are we? We're tracing a path in 4D spacetime.
That's exactly it. And that path has a name in physics.
The world line. That's what we're diving into today, isn't it? This key idea from physics, sort of pioneered by Herman Minkowski.
Yes. Understanding what it means for how we see reality, how we see time itself, it shifts perspective.
Okay, so let's start there. A world line. It sounds simple, like a trajectory, but it's different from, say, an orbit in 3D space. How?
Well, the crucial difference is that time is explicitly included. It's not just where you are, but when you are there. It's a sequence of space-time events.
Events. Okay, like points in 4 dimensions.
Exactly. Think about the Earth. We say it orbits the sun, right? A circle, roughly.
Yeah, it comes back to the same spot every year.
In space, yes, but not in space-time. Because a year has passed. It returns to the same spatial location, but at a different time.
Ah, so it hasn't actually returned to the same point in 4D.
Correct. Its world line isn't a closed circle at all. It's more like a continuous helix spiraling forward through time.
A helix.
Oh,
Okay, I can picture that. And we often visualize this using those Minkowski diagrams, time going up, space across.
Precisely. It helps map out this 4D reality, even if we can only draw 2 dimensions easily. It shows time as just another coordinate axis, fundamentally.
So if we're all tracing these 4D paths, these world lines, are there rules? I mean, special relativity must put some limits on these paths, surely.
Oh, absolutely. Big limits. A world line for any object with mass must be what we call a time-like curve.
Time-like, meaning
Its speed through space is always, always less than the speed of light. C. That's the universal speed limit. Nothing with mass can reach or exceed it.
Right, Einstein's famous constant.
Yep. And that speed limit, C, it does something fundamental. It structures space-time around any event. It defines 3 kinds of paths or curves.
Okay, what are they?
Well, first, the time-like ones we just mentioned, the possible world lines for matter, slower than light.
Got it.
Second, light-like curves. That's the path light itself takes, traveling exactly at speed c.
Makes sense.
And these light-like paths trace out the boundary called the light cone.
The light cone. Right, I've heard of that. It separates past and future.
Essentially, yes. From any given event, the light cone defines the boundary. Events inside the past cone could have influenced the current event. Events inside the future cone are ones the current event can influence.
So it dictates causality. What can affect what?
Exactly. And the third type of curve.
Let me guess. Faster than light.
You got it. Space-like curves. These represent, for example, the spatial distance between 2 simultaneous events for some observer, or a path that would require faster-than-light travel. So not a possible world line for an object to travel along.
Okay, that framework is clear. Time-like, light-like, space-like, all defined by c.
Yeah.
But what about the regions outside the light cone?
Ah, that's the really counterintuitive part. That region is called elsewhere.
Elsewhere, like that name.
In older Newtonian physics, you had this idea of a universal now, an instant shared across the whole universe, a 3D slice of time.
Right, seems obvious.
But relativity says no. That elsewhere region is, it's a full 4D chunk of space-time. It contains events that are neither in your past nor your future.
So you can't influence them and they can't influence you. They're inaccessible.
In a causal sense, yes. And critically, whether an event in elsewhere is past, present, or future relative to you actually depends on your state of motion. There's no absolute now out there.
Wow. Okay, that can be a concrete example.
The sun. We see it, but because light takes time to travel, we see it as it was about, 8 minutes ago?
Like 8 minutes in the past.
So the sun right now, its actual current state at this very instant, that event is in our elsewhere? We can't know it or interact with it simultaneously. It's causally disconnected from our present moment.
That really drives home the point about the finite speed of light. The present isn't this thin sheet. It's thick with unreachable stuff.
Exactly. And just quickly, related ideas. A 1D string traces a 2D world sheet. A 2D area traces a world volume. And in general relativity, under gravity, the world lines of free-falling objects follow special paths.
What are they called?
They're called geodesics, the straightest possible path through curved spacetime.
Geodesics. Okay, man, this whole concept, your entire history, just one single unbroken line in this immense 4D landscape. It's humbling.
It is. It changes how you think about existence.
It really does. I remember Kurt Vonnegut had this image. describe the heavens filled with rarefied, luminous spaghetti.
Hmm. That's actually a perfect, if quirky, image for all the world lines of stars, planets, people, all tracing their paths through spacetime.
Luminous spaghetti. I won't forget that. Well, this has been incredibly illuminating. A fantastic look at world lines.
Glad to explore it. It's a cornerstone concept.
Absolutely. And speaking of building things, if you need help bringing AI into your work, check out our sponsor, embersilk.com. They specialize in AI education and integration. That's embersilk.com. And if you found this deep dive as fascinating as I did, please do subscribe to the show. Hey, maybe even leave us a 5-star review. It genuinely helps get the word out to other curious minds. Thanks so much for tuning in.